In number 16, we're supposed to sketch the graph of 12x plus 8y minus 3, plus 3z minus 24 equals 0. This is a plane. Now, it's got all three variables in it, so that means it's going to be easier for us. This plane is going to cross all three of the coordinate axes, and so we just need to figure out where does that happen. So, for instance, where does it cross the x-axis? What is the x-intercept? Well, that's where y is equal to 0 and z is equal to 0. So the other two variables are equal to 0. So if y and z are both 0, then you're going to get 12x minus 24 equals 0, or I think that gives us x equals 2. And so for the y-intercept, we're going to set x equals 0 and z equals 0. Well, that's going to give us 8z minus 24 equals 0, and I think that tells us that the y-intercept is 3. And for the z-intercept, that's where x and y are both 0, so those will go away, and we're left with 3z minus 24 equals 0. I think that solves to be z equals 8. So, what I'm going to do here is just draw lightly a coordinate system. So there's the y-axis, there's the x-axis, and there's the z-axis. And I'm going to put all the intercepts on these axes. So I guess I'll put z equals 8 right up there. So I'm thinking of this as 2, 4, 6, 8. And then the x-intercept would be about right there. And then the z would be, the y would be 3. That would maybe be about right there. And all we have to do is connect up these 3 points with line segments. And I've got a pencil I can shade this with. All right. I think that is good enough. Now we're going to convert this rectangular equation, x squared plus y squared minus z squared plus 4z equals 0, from a rectangular equation to a spherical equation. I believe this is supposed to be a hyperboloid of some kind, perhaps a hyperboloid of one sheet. Anyway, so here are these equations that we can use to convert from one system to the other. So I'm just going to make some replacements here. So the x is going to be replaced with rho sine phi cosine theta. And I'm going to square that as the x is squared. Now for the y squared, we're going to have rho squared sine squared phi sine squared theta. For the z squared, we're going to have minus rho squared cosine squared rho, and then plus 4 rho cosine phi. And that's equal to 0. All right, so here's what I'm going to do first. I'm going to put these two together, and I notice that there's a common factor of rho squared sine squared phi in these two terms. What gets left behind is cosine squared theta plus sine squared theta. Cosine squared theta plus sine squared theta you will recognize as being equal to 1, and so we're left with rho squared times sine squared phi minus rho squared cosine squared phi plus 4 rho cosine phi equals 0. And the only other thing I see that we can do much work with is to take out a common factor of rho. So there's a factor of rho in each term. Let's divide everything by rho. I I guess I should say, let's divide each side by rho. That's more accurate. And off the top of my head, I don't see anything we could do. We might be able to use a double angle formula for this. This might relate to the cosine of 2 phi in some way, but I don't think that's really going to be all that helpful. So let's just leave it as it is. Now we were supposed to sketch the cylinder x equals z squared in space. So here's what I'm going to do. I'm going to first sketch it in the plane with x and z as the axes. Now, since x is the dependent variable, it depends on z, I'm going to make that the vertical axis, and then I'm going to make z the independent variable, in this case, the horizontal axis. Now, I want to draw x equals z squared, so that's going to look kind of like that. Maybe I should have scooted it over a little bit. But it's a parabola. Now what I need to do is transfer that over to the xz plane in space. So this is a parabola that's centered along the positive x-axis. I'll try to do a better job of drawing it over here. So it might look kind of like that. Alright, so that's supposed to be in the xz plane. I'll make this come on down here a little bit farther so that it sort of catches up with that end. Now, the original equation does not have a y in it. That means y is unrestricted. Y can be anything. So basically what we need to do is move, allow this shape to slide along the y-axis. So what I'm going to do is draw, as best I can, a copy of this parabola farther down the y-axis. So maybe it looked kind of like that. And then I'm going to connect up those 2 points, and those 2 points, and that. I'm going to pause while I shade this. Alright, so there is my figure shaded. So it's got this parabola shape here, and then it's like a sheet of paper that has been curled up a little bit, so it's in the shape of a parabolic trench, if you will.